Let's take a look here. Oh yeah! All right, this is from about 14.7 billion years ago, roughly. Does anyone remember what stem and leaf means? Stem and leaf. You guys, let's do it this way. Since you asked me about it, if anybody wants to try to do that, go ahead and try to set it up, and then I'll catch up to you. On number one. If in the meantime you have something that's more urgent, you can ask it. Oh yeah, those of you who just came in, do anyone need a copy of this practice final? Everybody else has got the practice final? You want one? Oh, that would help. There we go. Yes. Oh yeah, those I'll hold on to, because if it turns out you're close to something in your average, then I'll take a look at those, see if it boosts you up, you know what I mean? Yeah. So real quick, stem and leaf are very nice, right? What are the stems? Yeah. Does it go up to 13? Yes. Of course, they didn't give us enough room, but that's too bad. And then what do you put next to each one? Like next to the 8, what are you going to put? Yeah. You got 82, 85, 87. I think that's it. Oh, 89. Right? And you keep doing that. You keep going, and then what's the thing you put at the end? The key, so that people know how to read this. Because right now, this could mean 8.2, 8.5. So if I put a key down, people know how to read it. Cool. It's kind of like a scale on a map. Yes? No, you put next to the 11.
Oh, okay.
Because that represents 102 something, 100 and
So then we would just do a 2.
Yep.
Okay.
And that would mean 112. I like it.
So next to the 10 would be a 0.
Next to the 10 would be absolutely nothing. Don't put a 0 because that would mean there's a 100. You see that? If you put a 0 next to the 100, that would mean 100. I mean, next to the 10, that would mean 100.
Okay.
And we don't have 100, so it's just blank. Yeah. You guys all right with that? And then, do you guys remember what a frequency histogram looks like? What shapes does it have in it? Whatever that sound was, it was incorrect. Anybody remember?
Rectangles?
Yes, rectangles. Yeah. So for example, I'd have like, I tell you a class with a 10, and I think I didn't get too detailed It's like 80 to 90 to 100, blah, 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 blah. So 80 to 90 is going to go up to 1, 2, 3, 4. And the 90 to 100 is going to go up however high, however many numbers you find that are in the 90s. Does that sound at all familiar? Oh, look at some of you guys are looking at it like, are we learning this today, Jeff? No. This is from those first 2 chapters from eons ago. Many moons. So, okay. Did anybody get the 90s? How many numbers are next to the 9 in your STEM? 2? So then from 90 to 100, your bar is going to go up to 2. So it's a quick visual for somebody to see where most of the data seems to be. Number 2. All right. So I got a bunch of people with political leanings and potentially eyesight that needs help. Yes? What does that 2A, what does that question mean? What does that symbol mean? What is it asking me? PG. Is that a movie where there's not too much cussing? What is that?
The probability of
Yeah, the probability that somebody is green. No, the probability that somebody wears glasses, because they define G to be wears glasses, right? Okay, now, what is the fundamental idea behind all probabilities? What's the ratio? It's the number of things that divided by the number of. How many people wear glasses in this sample? 9 out of how many total people?
30.
So the fundamental idea of probability is based on counts. How many chances do you have to get what you're looking for divided by all the things that could happen? So you have 9 chances out of 30 to get somebody who wears glasses. So the probability that somebody wears glasses is 9 out of 30, and you can make that into a percentage.
For full credit, do we have 32%?
I don't remember. No, I guess not. I can't remember how picky I was about that. You just put 9 over 30, that's fine. I'm not gonna take points off. But it makes more sense to say there's a 30% chance. Because that's what that is, yeah.
Would B be, 18 over 30?
Kick ass. How many chances are there to get a Republican? 18. Out of how many people? 30. Bodacious.
The C and D are different, so.
C and D are different, that's right. What does C mean? What does the person do that I'm looking for? What's true about the person I'm looking for in part C?
Probability they're Democrat.
They must be Democrat and wear glasses. How many people do both? They must do both. That's what and means, right? And is the picky bouncer that makes less people get in. Only how many? 3 out of 30. So there's a smaller chance you get a Democrat who wears glasses because there's less Democrats who wear glasses in there than Democrats. What about part D? What does rug mean? Or, right? You or you, somebody. You. So that means I'm going to include all of the Republicans. I'm going to include all the people that wear glasses. Or is the nice bouncer, lets more and more people in. So how many Republicans do we have? Now here's the smart way to do this. How many people that wear glasses have we not counted yet? 3. So how many total people are Republican or wear glasses? 20. So if I do 18 plus 9, 18 Republicans plus 9 people wear glasses, what mistake am I making?
You counted.
Counted some people twice, right? Now, I could make a joke about some Republicans want to vote twice, but I guess it is. So we're not gonna count people twice, right? They only get counted once. Is that cool? Okay. Sorry. Hard not to do more of this. Is that right for number 2? So that's, I'm gonna give you a problem like that, because it kind of brings back set notation from 125 also. Right? And you're all like, dude, just live in this class. I'm like, too bad, no. What do you guys think about number 3? That's sort of a spatial reasoning problem. How would A work? Look at the original picture. What would have to be true? Like the original picture has a W, an X, and a Y. What did I do to the die to get it to look like this? Just rotated it, right? So is this possible? Is this possible? Yes. W, if I turn it, it's gonna look like that. X, right? X. And then there could be a U on the other side, I don't know. Is this one possible? What would this represent? How would I rotate the original? Shibboop. Yes? So if I do shibboop, then there's an X, there's a Y, and there could be a Z on the bottom. Process of elimination, you pretty much know that one of them is not going to work at least. Why does this not work? Yeah, what should be here? An X should be there. Kick ass. If that was the other way, then it might be true. I think. I have to think about it. But yeah, since that's not an X there, that's a different die. Is that okay? And then if I ask you a question like number, what is that, 3? The one about the symmetry? 4? There it is, Jeff. You could answer that by drawing the picture, although 4D, you'd have to draw an infinite number of pictures, so I wouldn't recommend that. 4C is a little bit evil, because in general a trapezoid, what do you guys think about a trapezoid? Does it have to have any lines of symmetry? No. But there is a type of trapezoid that has one line of symmetry. And it's actually the trapezoid that people normally draw when you're asked to draw a trapezoid. They normally draw this trapezoid, yes? That's your standard kind of trapezoid. Does anyone remember what this one's called? What do you think the base angles are? What's true about the base angles? What's true about the base angles in the like regular, not regular, it's a special word. In the normal trapezoid people draw, what's true about the base angles? They're the same. So what kind of trapezoid is that? We borrow a name from triangles. Isosceles trapezoid. So the general trapezoid has no lines of symmetry. If it's isosceles, it has one. You guys have it? So I would accept either answer since I was general. You'd say no lines of symmetry for a general trapezoid. I love you guys so much. We're almost there, guys. We're almost there. Ooh, yeah. If I were you to work it out, I would draw a couple of the basic regular polygons. What's a 3-sided regular polygon? What do we call that? Triangle. So draw it, but be careful, not a triangle. What kind of triangle? So yeah, equilateral, yes? And then see how many lines of symmetry it has, and then draw what's a regular 4-sided polygon. Square. And then see how many lines of symmetry it has. Yes? And then see if you can generalize. So there is a way to generalize it. So that's taking the idea of making a list. It's a visual list, but it's still a list. Finding a pattern, right? Those are two things from 125. Yes. 5? What? Do you guys remember doing this? Alright, everybody do this that wants to do this. We'll take out a blank sheet of paper. And make what you think is a set of perpendicular lines. By hand. Draw it kind of dark, you know what I mean? Like, so you can be sure to see it through when you fold your paper. This is sometimes muscle memory kicks in. You're like, I remember doing this. So how would you fold your paper to check to see if what you just drew is actually perpendicular? What would have to happen?
90 degree angle.
Sure, but how do you check that with paper folding? How do you fold the paper to check it?
Do you fold it up like I don't know, like that's the.
Yeah, there's two ways to do it. You could fold it at one line and see if the other line matches with itself. Or you can fold it at an angle and fold one line. Let me think how to say this. No, actually the best way to do it, I think, yeah, is to do it along one line and see if the other line folds on itself. If they're a little off, then it's not quite 90 degrees, right? Does that make sense? So fold one line onto itself and see if the other line folds onto itself. So we did that. I know, it's been a while. You guys getting that? You guys see that? Okay. I think we did one that was already printed out, and it looked like it was perpendicular, but it was just barely not. Yeah. Of course, the best way to check is with the protractor, but too bad. What's tricky about number 6? What's immediately trippy about number 6? Anything? Yeah, but we still have alternate interior. What's true about alternate interior angles if they are parallel? They're equal to each other. So even if they're not equal to each other, they still exist. So can somebody give me one pair of alternate interior angles?
3 and 6.
Say again?
3 and 6.
Yeah, 3 and 6. They're exactly what they sound like. Now somebody else give me, and then you can see there's another pair, yes? Give me one pair of corresponding angles. This is the one that people normally remember the best. Maybe not us, maybe we're different. Corresponding angles? 1 and 5, kick ass. They're the angles that look like they were created sort of the same way. What about vertical angles? 1 and 4. Let me ask, I'm gonna ask my part B question a different way. Which one of those, 1, 2, or 3, is always equal no matter what? 3. And the other 2 are only equal if what? If the 2 lines I gave you are parallel, yes? So then part B is straightforward. Which ones do you have to show are not equal? 1 and 2. 3 will always be equal, right? Vertical angles are always made the exact same way. They don't give a shit if they're coming from parallel lines or whatever. Yes? Okay, maybe? Whatever, Jeff. Math boy, spouting your math. Yeah.
8. How do you exactly do that situation?
Number 8 was. Oh yeah. Okay. So a few of you guys realized 8 was the one about x squared equals a, right? Okay. That was the one where I gave you. Let's see if I remember. You could just get the picture, Jeff. That's not quite right. Go away. Okay. Come and get your love. Okay. Yep. X. Yep. A 1. Yep. Okay. First off, I didn't really take any points away because the assumption is that they're similar, but can anyone see why those are similar? It's a little bit tricky. Can anyone tell me anything about these two angles here? What must be true about those two angles?
The same?
No. What's the only angle in that triangle that we know? 90. So what's true about the other two angles? They must add up to be. All three have to add to 180. So the other two that aren't the 90 have to add up to be 90. Okay, good. This angle is 90 minus this angle. Because I'm pretty sure, yes, I told you that it was 90 here. This whole thing is 90. Which means, so if I call this, not A, Jeff, if I call this B and C, this one would be 90 minus B. Is everybody kind of with me? Again, this is not something you had to do. I didn't make you do this. So which means I have a 90-degree angle in this triangle, I have a 90 minus B degree angle in this triangle, and I have another angle that I don't know, but they have to make 180, correct? So you get 180 plus C minus B equals 180, so I get C equals B. Why did I call this C? Darn it. It's okay. So then this ends up being equal to this, and I get angle. Okay. But you didn't have to show that. I didn't make you show that. The assumption was those two triangles are similar. You could show it if you wanted to. Some of you guys realized if I just rotate this triangle, if I just rotate it, you boop, I kind of get the similar triangle. So if I just rotate this guy, he is this one. Yes? So let me kind of do that. I'm going to take this guy. He's 1x. So can you set up ratios now? X is to 1 as A is to X. And then if you cross multiply, what do you get? Why did I just do that whole problem for you? I don't know. There's a freebie for your corrections. Damn it, Jeff. I was supposed to stop.
Yes, but it makes so much more sense now.
Well, yeah, sure. Yeah. Once you see it done, you're like, oh, there you go. Take advantage, Jeff, in his old age. Forgetting to stop. Okay. So some of you guys, I think a few of you guys got it right. Some of you guys actually said if you rotate that one triangle, it's similar to the other one. Like, you were right there. Keep going. I will tell you that is a little bit tricky. This is kind of cool though. It leads to a way to actually draw square root of 2 without measuring that distance. Just make x 2 and a would just end up being the square root of 2. But don't worry about that part.
but number 7,
Let's see. Oh yeah. All right. What do you guys? All right. Well, all right. Give that a try. Liz like, yeah, I already did, man. But hopefully it just kind of feels like it's right, but you have to kind of show me why it's right. One way to do it is to say, okay, assume it's not a rectangle, and then show that leads to a contradiction. Because what must be true about a parallelogram? What's the fundamental idea? In fact, we put it into its name. What must be true about a parallelogram? Opposite sides have to be parallel, yes. So if you take one of them and get a right angle, what's the only way that the other ones can't also be right is if they end up being not parallel to the other side. Now you have to kind of write that up. So that's one way to kind of approach this problem. Another way is something that I don't think I ever really directly stated, but what do you guys think about? What do you guys think about like those two angles? What must be true about those two angles? They must be equal to each other. Yes, so opposite angles in a parallelogram have to equal each other. And angles that are across from each other, like these two, what must A plus B be? A plus B be? 1A, yeah. So if you use those two facts, you can kind of reason out number 7. You can show that it does have to be a rectangle. That's probably a third way to do that, or a fourth way, a fifth way that I didn't even think of. Which is always exciting to me when a student comes up with a way I never thought of myself, and then I steal it. Next semester. First time I taught, I didn't know shit, and then I stole stuff from my students. Now here I am. Yay, I know stuff. I'm gonna go lighter on the final on, I think that the second test, I think, was that the one where I just gave you a ton of freaking shapes? It said find the volume and the surface area. I think that was the second. That's a grind, so I'm not gonna put you through that again. There's gonna be a few of them, but not like a ton. That's a bit much, right?
Slant length, oh my god.
Yes.
are you gonna have the formulas?
Yes. This time I'll actually write it up so you can read them. I mean, you type them.
Do we need anything for math kits?
Oh, yeah, you're gonna need your compass, and I can give you a straight edge if you need it. Yeah. I'm down to one good compass left, so if you need a compass, I have one you can borrow. And there's not gonna be a ton of stuff you have to do with it come by, so I mean, you can borrow, you can share it with other people if you need to borrow a compass, it's fine. Yes.
8,
What?
number 8.
Number 8? Lynn's like, come on, man, just keep going. All right, number 8, of course I like all of these, but has anyone considered number 8 yet? First off, what are vertex angles? What are the vertices? What would your guess be as to the vertices of this shape? I'm not sure I can describe it to me. Somebody's like, that.
One's in the middle,
No,
the one's on the outside.
sure.
Like, you expect the
These are vertices, right? So the vertex angles are this plus blah, 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 blah. So I want you to show somehow, without knowing shit about this, besides it's a 7 gone, I also drew in some triangles that should help. I want you to figure out how those all add up to be 900 degrees. Tell me real quick. Take one, no, alright, let's do it this way. You see how all the triangles come to a point at the center, correct? Okay. All the angles in the triangles have to add up to be what there? So like, right here. This angle plus this angle plus this angle, blah, blah, blah. What do they have to add up to be? 360, yes? You guys with me? How many triangles are there? 7. So how many total degrees if you add up all the angles in every triangle? Each triangle has how many total degrees? 180. There's 7 of them. So how many total degrees are we working with? You're all like, I don't know, man.
Didn't we have a formula for this?
Huh?
Didn't you make a formula for this?
Nope. Not a single formula would I give you for this, because you don't need a formula for this. You got them. You know there's 180 degrees in every triangle, right? You know there's 360 in a full circle. So I'm not using anything we don't know. So 7 times 180 is 1260, yes? I really want this to make, I love you guys. So, Jeff, you can draw on the thing, that's right. So watch, this kicks so much ass. Are you guys all with me that if I add all of these angles up, I get 360, yes? Kick ass. So these by themselves are 360. Every triangle has 7 times 180, 1260 degrees, yes? If I subtract this from this, doesn't that leave all of these angles? And isn't that, when I combine those, aren't those the freaking vertex angles? And sure enough, how much is left when I subtract out the middle angles? I'm just left with the vertex angles, I get 900. Doodle. You guys see that? So I drew those triangles in. Well, obviously I didn't do it because otherwise it would be a straight dashed line. I had a computer do it, but still, that should be a clue for you. I've got to use what I know about triangles to help me do this problem. And of course you're going to get a problem like number 9. Just a straight up, just, well, here's a bunch of stuff for you to convert, yes? Yes, I'll give you the same stuff you've gotten before. I'm not going to suddenly go, now you have to do them all. Oh yeah. So if you want to do anything specific on number 9, let me know, but otherwise you've seen those kind of problems before. Real quick, how do I do 9E? That's one that still gives people trouble. Yes, the best way to do this is do inch, inch. So then 12 inches in a foot, 12 inches in a foot. I got to do it twice, so I kill an inch and I kill the other inch. And then I can see how to get, and of course, what am I going to be left with? Foot times foot, foot squared. I think I ran out of room for 10A, so I was going to do it in class anyway. 10A is a little bit trippy. Can you guys see what the shit's going on with 10A? I didn't even stop to think about how that could be misconstrued, but. Huh? Say, yes. Trapezoidal prism. I love it. It's a trapezoid. So if I kind of draw out this face of it, and that's repeated along a length of 10. So that shape here is repeated. So if I just take this face and draw it by itself, just give me some creative license with, yeah. And then we know this is 9 up here. So in order to do this problem, I have to know this, yes? Yes? How do I find that? Once you find that, everything just falls into place.
Use the 5 to look at triangle.
Do it again.
You use the 5 to look at triangle.
Yeah. So,
Or right triangle.
a right triangle which kicks a lot of ass. So if I draw in that, we've done stuff like this before. That's gonna be the same height as this, yes? How long is this piece? Right there. 3, yes? Because it's 6, 9, so it's 3. And then what kind of right triangle are we working with? 3, 3, 4, 5. So now I know that's 4. So to get the surface area, you could use the formula, which is perimeter times height. In this case, it's 10, yes? And why does that make sense? If I take the perimeter, what am I trying to get in? Yes, surface area. If I take the perimeter of the repeated shape times the length, I'm basically adding up all the sides together. Then I have to add the areas of the two bases. So the two bases are trapezoids here and there. So let me ask you this. What are the dimensions of this rectangle face here? This rectangular face right there, this one. What's the dimensions of that rectangle? This rectangle right here. Well, it's 5 by 10. Yes? And then this one is 9 by 10, and this one is 4 by 10, so forth. Yes? So I really want this to make sense. To get this surface area, I would do 5 times, where do you go? Yeah, 5 times 10. To get this one, I would do 9 times 10. To get this one, I would do 4 times 10. And to get the bottom, I would do 6 times 10. So if I do the perimeter times the height, I'm doing all of those at once. So a quick way to do the surface area would be perimeter times height plus 2 area of the base, because I have 2 trapezoids. I've got the front trapezoid and I've got the back trapezoid. Now, to be really honest, you could just get all the areas of all the rectangular sides one at a time. That's the same thing as doing this. But this is all about what makes sense to you. This isn't about memorizing formulas. This isn't about plugging shit just straight into a formula. It's, why does the formula make sense? Is there a way that makes more sense to you? Do it that way. Yes? They're all based on reality. They're all based on what makes sense. Formulas at the end, look at this. What the shit's that? It has the idea in it. But it's easy as a student to just go, yeah, just plug shit in, I get a number, and I keep going. But it's much more important to understand why that works. Why does that work? Oh, Pete.
Thank you.
You're welcome. So, if I do this, what's the perimeter of the trapezoid? What's the perimeter of the trapezoid?
24?
Yes, thank you. And the height is 10. And how to get the area of this trapezoid? What do I do to get the area? We need it again for the volume anyway, so let's get it.
Was it 1/2, like the 2 bases?
Yes, 1/2. Add the 2 bases now. What are the 2 bases? 9 and 6. They're the 2 that are parallel to each other. Because they could both, you could rotate it and have it sit the same way. Okay. Sum of the 1/2 the sum of the bases times the height. So that's 30. So the surface area is going to be 300, I think. I didn't give any units, but you know I will on the test, so be careful. And then the volume of a pyramid, you guys, not pyramid, volume of a prism is just the surface area of a base times how long it's repeated for. So it's the area of the trapezoid times 10. This is basically 10 trapezoids stacked on top of each other. So if I know the area of one trapezoid and multiply by 10, so you get the volume it goes through. We already got the volume, the area of a trapezoid. You could do it, Jeff. Area of a trapezoid was 30. So this is neat. I made a problem where it comes out. I forgot I did that. Both the volume and the surface area happen to be the same number. They're not the same dimensions, but they happen to be the same number. That's kind of nifty. I like it. You wish. This part be okay? The numbers are a little big, but what shape is that, of course? Cylinder, yes. Now, one thing I'm realizing that Past Jeff really just flubbed this problem is, and I'm really, really embarrassed, but too bad for me. Past Jeff, doing this very quickly, read this as D equals 52. But that's C equals 52, yes? Okay, so if I actually gave you this problem on a test, I would explain it a little bit better. In order to get the, let's go to the volume first. In order to get the volume of a cylinder, I need to know the radius. How do I get the radius from what I told you? What's the formula for circumference? 2 pi r. So then what's the radius? (26 over pi). So then what's the volume? See, this is where you got, so, all right, is that what you want the radius to be? 26 divided by pi. Is that what you want it to be? Anybody? Because we're not weird. Just me. You don't want it to be 26, but it is. But who cares? You just chuck it in. Yes? What do I do to that in the formula? Yeah, the formula needs me to square it and then multiply by the height, which is 18. Now, I don't blame you if you just throw all that in your calculator. In fact, go ahead and do it this way. But be careful when you put it in the calculator. It should be pi times, parentheses, 26 divided by pi, close parentheses, squared times 18. So you square the whole 26 over pi. What should you get, Jeff? Hold on. Good Lord, I'm not going to do that. No. Screw it. You still want to? Yeah, I do. Let's see. That's roughly 6. And then that would be, I don't know what that would be. 6 25 plus 25. I don't have a clue what that is. Like 25? No, is that right? Somebody save me for myself. 1,000 times 270. Really? Is that right? That seems crazy. Oh, just 4 power. 1,000 divided by pi, like 300. Somewhere around 300 or something. What is it?
I got 3,800.
Oh, okay. Somewhere I flipped my decimal back too far.
Actually, this is how I wrote it out. I have the same thing.
Here, all right, I got you. I'm trying to do it in my head. I'm sorry. I moved the decimal back too far at one point in my head. So that makes sense. So let's see. It would be 26 squared times 18 divided by pi. That's one way to do it because one of the pi's cancels. And you're getting 3,000 something?
Yeah.
Okay. I believe you. Let's see, 2. That would be 50 squared times. You're still doing it, Jeff. I know. 4.5. I'm gonna stop trying to do it in my head. So 3,000 something? Okay.
Yeah.
And then surface area. Surface area would be 2 circles, right? Top and bottom. Plus the surface area of the side, which will be 2 pi RH. So of course that'll be a formula you'll just have for a cylinder, right? And now you plug 26 over pi in, throw in the old calculator, get your answer. Is that okay? So remember, when I give you the key, I did that one wrong. In my rush, I just saw that as diameter is 52, I think. But that says circumference is 52, so you gotta take a second to figure out the radius. You've seen a problem like that before from me, where I gave you the circumference, you had to figure out the radius. Yeah. And I'm hoping number 11, 12 is not too bad. I'm hoping. Let me go ahead and give you guys the answer key so you got something to look at. Oh, of course. Okay. I think I finished it. Anybody else need a copy of the practice file? Everybody else is good? Okay. Come get your love. Yeah.
Can you do number 7 on the quiz?
Quiz.
No, test 3.
Test. Oh. All right. So if we have triangle ABC, and we know that ABC is congruent to BCA, which means AB is congruent to BC, yes? You with me? So again, can't you take, so if I know triangle ABC is congruent to triangle BCA, you with me? I mean, that's what I tell you. Isn't side AB congruent to side BC? That's why I ordered it that way. So this side is congruent to that side, correct? But isn't side BC congruent to side CA? Yes? Which means all sides are the same, which means it has to be equilateral, because equilateral means equal sides. Yeah. That's the quickest way to do that one. There were some other people that did it a different way, but that's the quickest way. It's a version of the transitive property. I don't know if you guys. If A equals B and B equals C, then A equals C. I call it the property.
The real scheme for 5 too.
Oh, 5 on the test. Oh, Ralph. Okay, here's the right way to draw this Ralph picture. Yes. Ralph. Not to scale. This is 4 feet of shadow, and he is, what did I say, 12 feet away? He is 5.5 foot tall. So how long is this side total? Oh, are you about to die? You're like my last pin. Damn it. Oh. Let's see if you're alive. Okay. Are you with me so far? So the mistake people made was they made 2 triangles. There are 2 triangles, but they live inside of each other. His shadow exists because of this. Right? Okay. This is 16. And I want to know how tall the lamppost is. So call it H for height. So what proportions can you set up? The mistake people made is they said 4 is to 12. But it has to be 4 is to 16. Little triangle, big triangle. 4 is to 16 as little triangle, big triangle. Yes. 5.5 is to H.
We don't even need the
Hell no. I don't need anything about this slant, dude. This hypotenuse. Yeah. I don't need to know anything about it. So if you did any Pythagorean theorem, you didn't need to. Oh, 9 is a lot like this one. So I don't know if you noticed, let me see if I can show you this without giving away too much of this person's test. See the little triangle that's in the picture? So if I draw that little triangle, Jeff, just draw that little triangle. So this is the thumb. That's that little triangle, yes? This is 24 feet away, and then I have, this is the thumb image, I should say. And here's the actual thumb. So do you see how it's exactly like the Ralph problem? And this is 5 feet. This is 24 total, which means this is, doesn't really matter to be honest. His thumb is 1/6 of a foot long, so I really appreciate the person that converted everything to inches. That was not a bad idea, but you don't have to. 1/6 works really well with 24, so it'll come out nice either way. And now you just make ratios, because you know they have to be similar because they live inside of each other. We are making an assumption that his thumb is straight up. But yeah, I figured that was a safe assumption to make. Is that enough to go on? Is that all right? Yeah? Okay. So I gave you 2 of the exact same problem. One with Ralph's thumb and one with Ralph. Total. Yeah.
No, just right here.
No, you're fine. I understand. At first I thought you said equals, but you meant like in a ratio.
Yeah.
You're fine.
Okay. Okay.
I didn't take points off. At first I thought you said we're saying equals.
So what happened here? This one is, for example, here, right?
Yeah, there's another way to write it, but this is acceptable, I just misread what you wrote, yeah. We don't know that. Prove that if this, then this. So we don't know that. I want you to prove it. Prove that if we know this statement is true, then this must be true. So we don't know exactly. Yeah. Yep, that's true. Wait. Again, same idea. I don't know that it's that hard. I don't know that. We don't know that it's that hard. If that goes to triangles, if it is congruent to itself in this way, then it's equilateral. You got the parts you need on the picture, but you never referenced it. Yeah, why are all the sides equal? Asking for more. So, why are all the sides equal? Take me through the steps. So you kind of skipped a step. From the, be a little more specific, from the congruence statement I gave you, ABC going to ECA, whatever I said, pick out the sides and show me that they end up being all equal. Right, for example. Oh, okay, you can do it by angles. Yeah, you can do it by angles. Yeah, ABC must be BCA. No, you don't know. If this, then this. Yeah, we don't know this, we're trying to show it to everyone. So either you can say side A, go to side A. This can go to side A. There you go. And then side BC is congruent to side BC is congruent to side. If you say all of that, you've shown me all the sides are equal. Yeah. Oh, you want added instead of multiplied, yeah. You sort of added, or I'm not sure exactly. This looks better, let's see. Yeah. That looks better, yeah. Cool. Oh, all right. Oh, so number one, this one, right? So 6 is to 10, small triangle to big triangle. Yes? A side of the small triangle, ratio over a side of the big triangle, yes? As 8 is to x, that's wrong, because why is that wrong? Is 6 a side in a small triangle? Yes. Is 10 a side in the big triangle? Yes. Is 8 a side in the small triangle? Yes. is x a side of the big triangle? No. What is the side of the big triangle? There it is. So it's not 6 is to 10 as 8 is to x, it's 6 is to 10 as 8 is to 8 plus x. And I really like, one person did this, they called this whole side y. So they said 6 to 10 as 8 is to y. They figured that out, and then they subtracted 8 to get what x was. Cheers for that, that was awesome. You don't have to do it that way.
And then so, the first way you said that would be White's work, or the second thing is.
Yeah, Dwight's wrong, and when you talk to Dwight, I want you to say, "You are wrong." No. I say, "What is wrong with you? Psh, haven't you been listening to me?" No, don't say it. So you have to explain to Dwight why that's not quite right, and it's a really good idea to point out that x is not really the side of a triangle, so you can't use it in a ratio of sides of triangles. It's a very direct thing to point out, because that is very tricky. Yeah. And number 2, you said?
Yes, please.
Since you asked so nice. I'll try not to show somebody's work. I don't have a blank copy of it. So this was the one, oh, one mistake I noticed. Let me see if I can copy this down. Chaba! A, C, D, B. You could do it, Jeff. E. Okay, there we go. I did it. Go, Jeff. Okay, so I tell you that AC is 20, and that's an immediate mistake people made. If AC is 20 and CE is 5, how long is this? AC is 20, right? AC is 20.
So that's 15.
That must be 15, yeah. And then I also tell you BE is 9, and DE, I think I say, is 3. So then it should kind of jump out at you, the scale factor kind of business. So you got the correct sides right now. What else, what angle do you know is the same? What angles are congruent? I didn't tell you this, but you can tell. What? Vertex angles, yeah. So AEB is congruent to DEC. So now all you need is the rate, this side, this angle, this side. You need these to be in the right ratio with these. Yes? And of course realize that the triangles are sort of flipped from each other. Yes.
So we're gonna scale that from 3, right?
Scale factor of 3. Good. So that would be side, angle, side.
I was trying to do 3 angle, but the lines aren't parallel.
Yeah, exactly. You can't make that assumption. You could prove that potentially, but no. No, don't do that. You think it'd be wrong if I brought like a sleeping bag to my last class while I take the final and just take a nap? Is that wrong? That would be wrong. That would be okay?
Yep.
Sounds valid, right? They'll all be helping each other out and then just.
She'll like sleep in on Monday.
Huh?
Just sleep in on Monday.
Oh, just, okay.
Like during class, you can sleep in.
Thanks, Gabe.
Yeah.
You're so nice. It's okay, Jeff. We got you.
Corrections.
Oh, thank you. I need to remember where I left off. I love that show. I left off somewhere. I can't remember which episode I left off.
just started watching it on Netflix because it's like so popular and stuff, but they only have like 2 seasons. But they have it on
Yeah,
Netflix.
of course, I have not the most legal means of touching some of these things. I forget where I was lost. Thank you. Yeah, I love the idea. The idea is neat. Yeah. All for one versus one. It's beautiful. I think the first time he uses his powers, breaks his finger because he's supposed to throw a ball or something.
No, that is second time he uses the power. First time, both of his legs break, his whole hand gets swollen.
Oh boy, I forgot all that. I remember when he got that big robot and they were doing that thing. His whole arm was
Arms broke, both of his legs, and he only had one thing available.
yeah. See, I want to get to the point where he's like using all of it. I'm nowhere near that, so. I want to see that.
That video got it out, it's so cool how he like. Although I have no idea why. There's one video where it's like, his door versus his whole class, and it's like, what happened? What's going on with this story? I want to know, but it's like, Netflix updated things.
Yeah, 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 yeah.
So anyway, I can watch it. I have the other stream.
I know. I understand. I like Netflix because you can speed it up and speed up the video, which is good. Yes,
I get 3 A's in B.
what about?
On the test, 3.
Can you get them? I have faith in you, you can get them. Oh, all right. So 3A, I give you this and this. So you can very easily figure out all the angles are the same, but that just gives you similarity. It doesn't give you congruence, right? But I mean, what kind of triangle is both of those? I mean, you have to figure out the other base angle here. What's the other base angle? So what kind of triangle is this one? Asasasas. And then obviously, what do these two have to be? Now stop right there. Do you have enough for a congruence property to be applied? You only have one side, correct? So it's the only congruence property that works with just one side. Angle side? So you have angle side? You're done.
I didn't know we were allowed to draw in 75 degrees.
Huh?
I didn't know that was allowed, like to assume it was an isosceles.
No, we're not assuming anything. Well, I know this one's isosceles because these two are the same.
Oh, okay.
In which case, if that's 30, these have to add up to be 150, and they have to be the same, so they have to be 75. So they must be 75. I'm not assuming anything. Yeah. And then you said 3B?
Yes.
If you look at that second triangle, right? What does it give us? Yep.
It gives us side angle side.
No, the second triangle.
Oh, sorry, the side
Side angle, right?
angle.
So two things, it doesn't match with the other triangle, and side angle would never give it to me anyway.
Yeah, so I put that they aren't congruent on here.
You have to give me some reason. Plus, you can't say they're not. We just can't say they are. Do you see the difference? I cannot say that they are congruent, but I also don't know if they're not congruent. I just don't have enough information. What I've been told can't lead to congruence because they don't have the same angle in the right place, and one of them is SSA, which would never lead to anything, right?
Okay.
So any combination of those words would work as an answer. But do you see the issue?
Yeah, because I really don't match up with one another, like, not they are in the same order, that's why the two triangles.
But do you see how you can't say they're not congruent? Because somebody could give me more information to find out, oh, they are.
Okay.
You see what I mean?
Yes.
And they might not be drawn to scale and all kind of business, yeah. So, so you gotta be careful, yeah.
So they're not necessarily congruent?
They're not necessarily congruent from what we know.
Okay.
It's a good life lesson too, because a lot of people make these false dichotomies. If I can't say it's this, it must mean it's not that or whatever, and it's like, no, you just don't know. You can't say either way. I will be bringing some snacks on Monday for me to eat and you to watch, and I'll share some with you. I'll share some snacks with you. If you were here last semester, I must have done the same thing. Yeah, I'm sorry, do I bring bad stuff? Alright, you made a face like. Okay, I always bring stuff I like, so in case nobody eats that.
Maybe any like there?
Yeah,
Oh, there was?
yeah, there'll be some food.
No, I mean like, you know how last semester?
Oh, I don't know. I was thinking about doing one construction where you can come up and show it to me, but I'm still thinking about whether I wanna do that or not. Yeah. Yeah.
I have my chapter 14s. I forgot to bring them to you yesterday.
Oh, so you're turning them in?
Yeah.
Gotcha.
I forgot to give them to you when I made up my thing.
You're fine.
And then my test correction is here.
Sweet.
And then they're 2.2, I gave it to you.
Yes.
And then also I redid 13.3 and 4, but I just didn't get it back. I just don't want it to feel like I've done it.
No, they're there. I just, to be honest, I grade the final. And then if your former corrections might boost you up above something, then I look at it. If they wouldn't, I don't.
Okay. I went to see what my
Sorry?
because my test wasn't.
Oh, I gave it back to you, right?
Yeah.
That's great. I was just being worried. I don't have my spreadsheet with me. I left it back in my office this morning. I gotta make sure that. I might not have put that in there, which is weird.
Well, but I made it up yesterday.
No, I know, but
Oh.
I shouldn't have given this back to you if I don't have it in my spreadsheet. Is everybody else all right? You guys good?
Yeah, I'm just writing.
I'm gonna run back to my office, so I'll be there if you need me. Yeah, you have a moment?
Yeah.
Okay, good. Let's go put that in and we can take a look at what it should be.